What the heck is going on, guys? Welcome to your fourth biology video, and in this video I want to start off by talking to you guys about chemistry. Why do I want to talk to you guys about chemistry if this is a biology video? Well, if you think about it, biology kind of is chemistry. What the heck do I mean by that? Well, think about it. Take you, for example, since you are a living thing, and that is the, definition of biology. Well, you as a human being are made up of organs. Now, your organs like your heart, your brain, your skin, they're made up of tissues, which is made up of cells. Now, I know we didn't talk about what a cell is, but a cell is basically made up of different pieces called organelles. Now, these pieces called organelles, if you break them up into small enough pieces, then you end up with chemicals, just chemicals. So basically, if you take any living thing and break it up into small enough pieces, then you end up with chemicals. So that's why, in order to really understand biology, you first need a very basic understanding of chemistry. Now, you don't need to be an expert chemist in order to understand biology, but you do need to understand some stuff like, I don't know, matter and mass and atoms and, I don't know, elements, maybe isotopes, protons, neutrons, electrons, different kind of bonds like ionic and covalent bonds. So if you know these very basic things, you're ready to move on with these biology tutorials. But if you don't understand what those things are, then you're better off watching my chemistry tutorials on my website, thenewboston.org first, because even in this video, I'm going to be talking about some things and you may not be able to grasp the concepts fully. So go ahead, if you don't understand the very basic concepts of chemistry, watch those videos, then come back to here. But if you do, if you ever took a chemistry class or something, or read a chemistry book, you're ready to move on. So let's go ahead and talk about what I wanted to talk about in this tutorial, which is acids and bases. Now, before I discuss that, I want to go over molecules versus, wow, that's a nice looking S there, Bucky. Molecules versus compounds. Now, even if you studied chemistry before, people often get molecules and compounds confused. So, a molecule is basically two or more atoms, and you guys should already know what an atom is. And a compound is similar, but it's a little bit different. A compound is a molecule that contains two or more different elements, such as, let me draw it so it doesn't look like a pair of boobs. Something like this. Maybe a compound. So again, that's what a molecule is, two or more atoms, and a compound is a molecule that contains two or more different elements. Now, the reason that I wanted to explain all that is because whenever I talk about acids and bases, I'm going to be using, that terminology, and I didn't want to get you guys confused. So let's go ahead and do that right now. So, first of all, what is or what are acids? Well, it's not the street drug, or actually, LSD is kind of, it is an acid, but we want to talk about how to make drugs right now. An acid, in, the biological definition, is a molecule that can split apart in water, and whenever you add it to water, it releases hydrogen ions, H plus, a positively charged hydrogen ion. So the most famous example of this is actually hydrochloric acid, which is one hydrogen and one chlorine. And whenever you add this to water, it breaks apart and it releases, or it splits into, a hydrogen ion right there and a chlorine ion. But the reason that this is acid is because it releases a positively charged hydrogen ion right there, and that is the requirements for an acid. Now, the opposite of an acid is called a base. So let's go ahead and talk about bases. BASES, in case, maybe you can't read my handwriting. But a base is a molecule that splits apart and releases hydroxide. Now, hydroxide is OH negative, and remember, anytime you see a negative, that means it's an anion or a negatively charged. And what this pretty much means whenever something is negatively charged is it has an extra or more electrons than protons. Now, the most, I want to say, famous example or famous base, the example that biologists always give whenever they teach a class is something, is sodium hydroxide. Now that's Na for sodium and hydroxide, OH, hydroxide. Well, you see what's going on. And whenever you add this to water, this is going to split apart into a positively charged sodium and a negatively charged, I was going to write "and" like that, but it's probably not a good idea with that positive charge right there, and an hydroxide anion. So basically, why is this a base? Well, the requirement for a base is whenever you add it to water, it releases a hydroxide, and hydroxide is OH negative. That's the chemical formula. Now, that's nice and all, but this kind of looks like chemistry, and we were talking about biology. So why the heck is any of this important, and why do I even need to know it? Well, the reason that it's important is because these charged particles, such as this hydroxide right here, and also the positively charged hydrogen ion before, whenever well, you know what? Actually, I'm going to talk about why they're important in the next tutorial, but sometimes if you have too much of them in your body, it can cause some real trouble. But I'm going to save that for the next video since I'm getting kind of long in this one. So that's what an acid is. That's what a base is. Once you understand, you're ready to move on to the next video. Thank you for watching, and I'll see you next time.